And you can hear my voice okay?
Yes, it's okay.
Great. Well, nice to meet you, everyone. Thanks for joining my session on API security and performance testing and how to avoid getting in the news. So in this talk, oops, hold on. Thank you. In this talk, this is about me, but we'll move on. We have about 20 minutes, so I'm going to keep this tight and quick. We're going to be talking about APIs, why they're important, and why do we need to test for security and performance. And I hope you understand why that's so important. Just reading the news in any given day, you'll hear about things like data breaches and systems going down. But that's not the most important thing. The important thing is, how do you plan for success? It's easy. If you don't plan, you will have failure. But planning for success is the hard part. So in this talk, I'm going to be going through how you can plan for success, and then I have some specific things you should look for when planning about performance testing and security testing. In 20 minutes, I can only scratch the surface of this topic. There's a lot more obviously to learn. So I have some additional resources, and you can reach out to me on LinkedIn to learn more about the topic. So first things, what we're going to learn, we're going to talk about why you should plan to test security of your applications. We'll learn why it's really important to measure the performance and test the performance. It's a little bit different than security. We'll talk a look about the factors that can lead to poor performance and security, and then I've got some tools and suggestions of things you can use to actually make things better for yourself. Okay. So first of all, why are APIs so important? I hope that this is apparent to everyone on the call, but just in case it's not, an API is a piece of software that communicates with another piece of software. Okay, nothing special there, but the really cool thing is, because of the way APIs are designed, it's like a contract. You can actually have two pieces of software written by two different companies independently connect to each other. So Google Maps, for example, writes an interface. Everyone in the world can build applications on top of that interface without having to actually know what Google is up to. Google says, this is the API, so the way it's going to work, this is how it's going to operate, these are the results, this is the JSON you get back, or whatever format you're using, and you have confidence that the version of that API that you're using will work in a predictable way time after time, so I can use that and build an entire business around that. Without Google Maps, there will be no Uber, there will be no food delivery. A lot of the things that we're using heavily right now would not work. So APIs are critical to the functioning of the modern economy. So, okay, so APIs are important. We know that now. What about security and performance? Well, here's some examples of when performance was not taken into consideration. So the United States launched a website many years ago to improve healthcare access called healthcare.gov. It was a huge centerpiece of the previous Obama administration. It was the biggest piece of legislation they passed. On the first day, as you will know, if you read the news, it crashed and was inoperable, required people to use call centers. And I think to this day, it's still, I think, damaged the branding of the entire Healthcare Affordable Care Act, and I think it made it much harder for the administration to recover. And they have recovered, but it really took a lot of work to bring back the confidence in the platform and in the whole initiative that it was behind. And it crashed because a lot of the Data Hub APIs at the back end couldn't handle the performance. It wasn't necessarily the website they built wasn't fast enough and wasn't able to handle the load. That's easy. It was all the back end services that they had integrated with for all of the payment processing, all the eligibility tracking, all the APIs it relied on. They weren't tested for scale, so the whole thing crashes because without that data, the website can't work. Another example on the retail space was a retailer called J. Crew, which recently declared for bankruptcy, but this is 2 years ago. During the biggest sales day of the year, which is the most important day for most retailers, their apps crashed, their in-app mobile app crashed, their website crashed, everything crashed. And then when they traced it back, again, the mobile app was scalable, the website was scalable, it was all good, they tested it. The API for payment was not tested. The payment gateway was the bottleneck in all their systems, mobile, web, even in-store kiosks, and when that went down, it shut everything down. So again, two cases where a lower level API that you rely on isn't working. So if you are developing APIs or you rely on APIs, even if they're not your APIs, ultimately your business may depend on them, and you have to make sure that they work as expected. The next thing is security. Security is really important also, maybe more important actually, because if the system goes down, and you can't get business, you lose revenue. If you have a security problem, you lose revenue, but you also potentially get sued or you get fined by a regulator, which is worse. So an example I have here is, these are all public examples, was the IRS breach, which happened in 2015. So if anyone ever applies to college in America, you have to get your transcripts from your tax returns sent over to your college application, so they know that you make as much money as you say you do, so they know how much money you're eligible for in subsidy or none. And so they had a get transcript API, which was used internally between the college systems and the tax systems. Well, they didn't secure that because they figured it was only used internally, but it was accessible to the internet. Okay, great. What happened? Someone found out this API was there and got access to everyone's tax information and sold it on the dark web, potentially. Now, the thing is, this API was hidden, and so that goes back to a classic security failure, which is obfuscation is not security. And people think of that with websites. Don't have something stored in a website URL that you can access. Don't put something in an Amazon S3 bucket without knowing about it. Those are good things not to do. But if you have an API, APIs are kind of hidden, and because they're hidden, you must forget. This API is only being used by our internal team, but it's on the internet because we couldn't be bothered, putting it into a VPN. Well, it's a public API now. It may not be a documented public API, but it is an API. So security is important. So hopefully these examples, and there's one last one, which is the scariest one probably of all. This was where you had a device that you would put in your home. It was a GPS device for a phone system, so that kids' watches could be tied to their phone and they could track them using GPS and know where their kids were, and it was great. So parents could figure out what their kids were doing and go out after school. They could see who friends they were hanging out with. Makes your kids safer, right? But I don't know if I agree with it as a parent. It's very micromanaging, helicopter type parenting, but some people like it. Anyways, certainly if your kids are doing a lot of stuff after school, it could be useful. However, it wasn't secured. They didn't use TLS SSL security on the API. It was all done in clear text. The authentication of the authorization wasn't done properly. So you could retrieve people's information about their children, and you could find them on GPS. So if you're a sexual predator, this is the sexual predator procurement application. Lets you find kids on demand. Great. So let's just say this company probably doesn't exist anymore, and I'm sure whatever's left of that company is surviving or trying to survive a wave of lawsuits. So it's really, really important. That one developer who didn't secure the API, or that one team that didn't build a secure API, literally destroyed a company, destroyed a business, put people's lives at risk through bad security. So specifically when you're dealing with children or consumer applications, the risks are very high. Business to business can still be really high. If you're dealing in Europe and you have a GDPR dependency, if your company is subject to GDPR and you have any kind of data breach, there are very large fines for that kind of situation. Other countries are now following suit. Australia, Canada, other parts of the world are following California and the United States. It will be eventually standard that in every country that if you have a data breach and there was some degree of not following industry best practices, you will expect to have major repercussions. So in this case, this is clearly not industry best practices. So I think you'll agree, security and performance, two of the most important things with APIs, and I think you'll probably unfortunately agree, two of the most forgotten things as well. Okay, so keep going. So that's the impact. You wake up with in the Washington Post or whatever your local news source is, and you don't want to be that person's face. And it wasn't him actually, but that's on the right. But you don't want to be in the data breach for the federal workers when someone's stolen all their information, especially when it's the government. But you don't want to wake up in the morning and be here. It's not a good place to be. So let's talk about how you plan for success. So the first thing is you've got your APIs, and your APIs, you've written the APIs, then you're going to write some functional tests. These tests make sure that the APIs work as expected. Okay, good. And you have automated tests that do that. You have a test plan, you do the tests. Then what you need to do is define your security context and at the same time define your API usage, your SLAs. How many people are going to use this as API, peak, and so on. We'll talk about this a little bit later. But define those two, and then you build your test plan around the security and around the performance context that you need. My performance requirements and security requirements are not the same as yours. Particularly my performance requirements are not the same as yours. Security requirements tend to be much more similar because in the end, there are best practices and it's more of a binary. Are you hacked or are you not hacked? So an important thing that people forget to do, first of all, is let's identify all the APIs you have. What do you have? Do you have some SOAP APIs from the old days? Do you have some REST APIs? Do you have XML? Do you have JSON? Do you support many versions? Do you support internal APIs? Do you have RSS feeds? Do you have GraphQL? Each of these is an API. Maybe you've got some APIs that aren't what we think of as APIs. It's just a place you post data to, you upload files to. It's an API, though, if it's machine accessible. Um, look at the security context, understand the usage capacity. Every single endpoint is an attack surface. So one thing to think about is, do you want to retire APIs? If some APIs are not secure, if it's too hard to fix, maybe you have to communicate with your suppliers and users, and you need to retire them. Make sure you understand these. This is the first thing. Until you know what you have, you don't understand the testing effort required. So now we're going to go a little bit of a deep dive into performance. Performance, three things: reliability, scalability, and performance. Reliability, is the API always going to be available? Scalability, as we start to add more people to use the API, is it going to continue to work? And the third thing is, which is the next layer, as I add more people, so it scales, does the performance continue to be good? Because it might still work, so it might be reliable, it might grow to handle a number of users, but the time taken to use the API might degrade. So it still can be reliable and scalable, but not offer performance. Understand what your service level agreements are, which is your legal contract, if you have one, and then also define your service level objectives, which is what your goal is. Make sure your goals are higher than your legal agreements. You need to have a buffer, an engineering buffer. Management reserve, as we call it. So that's what we recommend you do. Identify your goals, validate your endpoints, understand your SLAs, and then put together the plan. And the plan would be understand your goals and your baseline metrics. And the other thing would be you need to choose which are the most important goals for your testing effort, because you want one set of testing effort would be, do I want to understand how good is the system? Is the system able to handle the load at the current design? That's one goal of performance testing. We know that if we put this many users, it will work this way. The second thing is more around the scalability, which is, as I start to add more users, what's going to happen? Another goal of this testing effort would be, I need to prove my SLA, I need to validate my performance and validate my scalability. That's different. That's saying, do I meet my SLA? Baseline metrics is saying, how fast does it run? Performance validation is like, does it run this fast? Another thing would be, well, I know I can meet my metrics in general usage. I know that my SLAs are going to be met, but I would like to know, what's the wiggle room? How much gap do I have between my goals and my agreements? So do a stress test. When does it break? And then you'll know truly where and that also will help you understand how close are you to. And maybe you need to put in something, a bottleneck in place. If you ever hit that load where you know it's going to break, you should know that ahead of time. You can put in place things like throttling mechanisms, a cloud watch system where it basically queues the requests. There are things you can do if you know your stress point. And then, of course, another goal might be, what are the key bottlenecks? These are bottlenecks that might not necessarily be breaking the system, but as we start to re-engineer and add more users and add more load, doing a proactive goal around where are my bottlenecks. So these are, and then planning for growth is another one. So these are all different goals of your testing efforts. Choose which ones you're doing. The danger is people say, I'm doing a performance test, and they try and test all of these at once, and they've no idea what's improving. And then you make changes to the system, and you've got no common baseline. So take one of these goals and do a test with it, then do another one and document everything, and make sure you have different test plans. It is going to be the same tools you use, but the load is going to be different, the test you'll be doing it different, and the results and the action items will be different from each one. So this is a good diagram to think about this. Take all of those different endpoints that you have, your mobile, your web, all the different pieces that go into your APIs, because your mobile app uses your API, your website uses your API, your service clients that use your API directly, they may be using your API. Understand the different people using your API and actually test for those too, because a web browser using an AJAX call is going to be a different type of API call than a machine API call, which is going to make the same call 100 times, run off another. A web API is going to make a whole bunch of different calls in a series of patterns. So it creates a different load on the system. So it's really important to understand the usages of the API, and these are your three general categories, I would say: machine category, mobile, and web. Confirm your SLAs, make sure you understand what they are, and then once you take your SLAs, as I mentioned, create your internal SLAs are your goals, or SLOs they're sometimes called, service level objectives. Basically, SLA is, you have to meet this or you don't meet the letter of your contract. the SLO is, well, we know that's a contract. We want to be twice as fast as that. That's our objective. We build to that. That way we have a buffer if it fails. As part of your understanding your SLAs, and ultimately your SLOs that come from that, or your internal SLAs, you'll look at things like geography, times, those types of consumer. Is it a web app or mobile? What's the distribution of all these different things? Is it all coming from one geography? Do we have an issue where some of the routing infrastructure is not going to handle it? It may be outside of your control, but you still might be in your contract. So it's important to know. Some tools and infrastructure, understand the environments. You're not going to probably be able to afford, certainly very large customers may not be able to afford the production environment, so that's okay. Do some basic testing in your test environment. Scale your test environment to 10% of your production. Do a bunch of tests in that environment with, say, 10% of the load. If that passes, okay, that's good. It's not good to say you should go live with that, but it's good to know that you don't think you have a problem. Then put into a staging environment that's 50% of your production environment and ramp up the load to maybe 50, 60% to see how it's going to handle it. And then as you go into production, obviously you'll scale to the full size. If you can make staging the same size, that's great, do 100%. But the thing is, if it fails to test at 10% load in a test environment that's 10% scaling, don't bother going any further. You've got some problems. So you can do a lot of testing before you get into the later environments. Before we go, yep, that's right. So here's in general how we recommend you would plan it. First of all, model the load, create your scenarios, do some monitoring, use the various tools we're going to show at the end, and then take your load, take your output from that load, and not only are you going to be then redoing the test, you will also be redefining the test itself, because you'll find, based on what came out of that load test, you're going to find, for example, certain loads were not realistic. The system broke really quickly in this test, but the reality is when you've done some user testing, it hasn't broken in the same way. Or maybe you find that the machine testing broke, the API, when you're modeling a web API, web usage of the API didn't break. So you might find that the actual performing of the test means that your load test and your data that you're using in your ramp up models are not necessarily a good proxy for reality. So it's an iterative model. As you basically do the test, you improve your testing. So it's important to think of that. Your first limited load test on your 10% environment using your basic scenario is just to get you some initial data that you use to improve the test. So it is an iterative process. It's not going to be you get it right day one. And the other thing I would recommend is do some scenario testing. So that means testing across multiple APIs. So first of all, you're going to test each API individually. Okay, API 1, create a user, API 2, create an account, and so on. Very good, that's fine. But then you're going to have to quickly scale it up to having end-to-end testing. Do these 5 things in order that a user might do that, because you might find there's some contention and there's some dependencies that your individual tests won't find. Okay, it's really important to put your performance tests into your pipelines. It's very important to have monitoring, shift left and shift right. And here's some tools and infrastructure. I've just picked some random ones, some open source and some commercial ones. If you want to reach out to me on LinkedIn, I can give you a lot more as well. Okay, on to security. We only have a 20-minute session. It's really tight today. So first of all, like we did last time, we're going to figure out what APIs we have. We're going to catalog the attack surface. What can a tester do? What can a hacker do? Same thing, really. What are our test methods? How do we monitor that? How do we make sure that our APIs are fit for purpose? The big difference between performance and load testing and security testing is load testing is if the performance of the system is slower, the business risk is someone's going to use your competitor. You can accept that risk and decide whether to invest in that. Security testing is much more on or off. You're either a security or not. If you're hacked, you're hacked. It doesn't matter that you did. We fixed 90% of the vulnerabilities, but we still left 10%. Well, that's not really good enough, is it? For performance testing, that might be good enough. So it's very different. It's much more of a binary approach. Same thing, understand your attack surface. You've got web applications that hit your APIs. You've got mobile apps that hit your APIs. You also have a generic system endpoints that are going to connect to your APIs as well. There are many methods for testing your APIs. These are just some of them. Can you authenticate? Am I who I say I am? Can I authorize? Can I do what I'm supposed to do? Can I send null data? Can I upload massive amounts of data to your API and it doesn't blow up and expose data back to me? Can I get a list of users? Can I get a list of accounts just by trying different numbers, which is this enumeration? Can I fuzz test? Can I try random data and see what happens? Can I inject SQL commands? Can I inject cross-site scripting? Can I tamper with parameters, change the parameters to change my profile name or something like that? Basically say to pretend I'm something other than I am. Change the account ID to a different account ID. Am I checking for that? For range testing. There's lots of different things. This is well beyond the scope of my talk, unfortunately, but these are great things to look up online and find out which ones you should use. You should probably be at least looking at all of them and then decide which ones make sense. Another really important thing about security testing is do some of it early. Do it in your CI pipeline. Do basic tests as quickly as you can, easily as you can into your pipelines. And then as you deploy into staging and production, use more detailed, more time-consuming pen tests and vulnerability tests. Sometimes you have to test, well, certainly later on, you should be testing the environment. So on a CI pipeline, you don't really care about necessarily the SSL version or the web server because it's not the real one. You're testing your code. There's your code of vulnerabilities in it. When you get to the actual later testing stages in staging and production, you've got to test that the environment is secure. Not just the code that you wrote, but all the libraries you use. That can be done in CI, but things like the infrastructure, the web server, the SSL, the routing, the ports, the firewall, the versions of the web server, the versions of the app server, Tomcat, and so on, the database server, all of that stuff needs to be done in staging. So staging needs to be an exact replica of production. Unlike performance testing, where you might have a 50% replica, as much as possible, you should have an actual replica. Don't use a self-signed certificate. Use your actual certificate. It should be exactly the same as production. And ultimately, you should still test in production. Test in production for security because someone may have forgotten to patch production. Maybe Windows Update's broken on the production server. You want to be the one who finds out that. You want to be not the person who's doing the hacking. And for security, there's lots of different tools. There are some general tools that you can use that are just general web service testing tools, API testing tools like SoapUI and Postman, other tools on the market as well. That's fine. Those are really good for doing some of the security testing, especially if you're doing things like parameter tampering, fuzz testing, things where it requires on the knowledge of your application specifically. But there's also some tools like Burp Suite and OWASP where they'll do some general testing for some general best practices. So depending on what you need to test in CI versus what you're testing later, use different tools. When it comes to things like pen test tools, there's a lot of services out there, Control Scan, Saint. There's a lot of commercial tools where it's a service. You give them your URL, and they literally will scan it and come back and say, hey, you're on TLS 1.1. You've got this cipher running. You've got, we were able to upload all this junk into an API, and guess what? It really resulted in a cross-site scripting. So they can do a lot of that sort of testing. Another thing I would just mention is test the API and the user interface together for security, because you might have someone be able to load in some JavaScript through an API call, which then when rendered in the page creates a cross-site scripting error and the reverse. So you may have interplay between APIs that you have because they're often more vulnerable because they're machine accessible, and you may have an interplay with that in your user interface. So don't treat them in isolation, do look at them together. So to wrap up, APIs are the most important part in many cases of the modern economy. I would say actually more important than applications, because if an application goes down or is a vulnerability, you have one set of users. With an API, you may have hundreds of people using it. And not only do you end up with compromising potentially your business, you compromise their business. If your business is hacked, who's going to bear the brunt of that? It could be all your customers. If your system can't handle the load, they're not going to blame your API. They're going to blame the person using your API that they're acting on. But that person's going to remember that, and you're going to be out of business pretty soon. So from an industry perspective, API testing is the most important things, and yet I think it's often the least important in terms of people's testing plan. They run Selenium scripts all day, they do all the security testing on the website, they check for cross-site scripting, they don't check their APIs are secure. It's the backdoor into the system. If you've got the hen house, that's what you should be guarding. So with that, I'm going to move over to questions.
Please drop your questions via the Slido platform.
Okay, I see some questions coming up. Hold on. What are the key indices you use to measure the performance of the system? The key indices, I mean, there's lots of different ones, things like, the page views per second. The most important one for an API, though, is actually usually the number of requests per second you can handle and the time to respond. And there's no right or wrong answer to that. But the two biggest ones we always come across are, how fast can this API call return back? And if I make 1 billion API calls, does it stop working? So number of concurrent calls and time to respond. Realms test management tools. We actually sell test management tools, so it's an interesting question that you asked that. I would say they're very important. Test management tools are very, very important because the problem with security testing, performance testing, is it doesn't give you an idea of risk, particularly performance testing. But security testing also, because security testing, you've got all these tests running in these different platforms. Where do the results come? The danger is all those results are going to be in some dashboard that the executive is not looking at. And the danger with performance, the problem is often that I've got the whole system being performance tested. Which of my features is more important? For example, performance testing, I'll give you the example. Do I care that the administration site is slow, that my 10 users use, or do I really care that the front end of the web that the user is accessing, the login API or the payment API that everyone uses, that's not working fast enough? So if the admin API or the third-party supplier API that's used infrequently doesn't have high performance or can be flaky, the performance is unreliable, I might be able to live with that. So things like test management tools, if they're run correctly, where you have requirements, you have your user stories, you have your SLAs, all of that needs to be stored in the system so you can tie back your results to understand, am I meeting my SLAs with performance? Now, with security, where it's more of a binary decision, the danger with security is always going to be, if you can't value it, people aren't going to pay for it, and people aren't going to do it. So the problem is you have all these user stories, you have all these unit tests, people think of the boards, the functional requirements, and the problem with just something like Jira, I think, is that you think of just functional requirements. You don't tend to put in your sprints the non-functional requirements. So a more robust test management system, and especially with requirements traceability and be able to tie back to risks, things like that, is really important because it lets you really categorize the business value and business impact of the non-functional requirements, of which security and performance are two of the most important. But things like usability also. So I think there's a big fallacy. If you have pipelines and you have a bug tracking tool or a simple agile planning tool, you're missing the point that the value and the impact is not going to be communicated to business users, and they're the ones who pay for everything. So next question is, currently I do not have any automation in place in my project, but now I want to implement automation. This is a more general question than performance and security. First thing I would do is and automation in general, first thing, figure out what's the most important thing to automate, what's the most repetitive task, what's the most stable. That's automation in general. I think, but for performance and security, it's a bit different. Performance, I would say, figure out the most important part of the application that you need to be able to not go down under load. So let's say it's the login page, because if that doesn't work, it doesn't matter, you can't go anywhere else. So take your login page, build a performance test around that only. Just pick one thing. So for performance, it should be driven by the most important from a bottleneck. If this goes down, it breaks everything else. If it's for the API that controls that login call. For security, I would, it's a bit different with security. I would actually start maybe backwards, run a pen test, do a simple pen test. That'll tell you where your problems are. If you get a pen test that's negative and says, okay, you have all these problems, then you need to start building out more detailed application-specific tests, like tests for cross-site security, tests for people authenticating, putting the wrong IDs in their passwords, putting URLs that spoof the path, using the wrong account ID. There's a lot of things you'll need to do with security testing. Much of it's going to be app specific because your API is going to be very specific to your domain. But do a pen test first. It'll tell you how bad you are, and then you'll know which of those areas, authorization, authentication, you'll get a sense of where the problems are. So it's a bit different for security. Open source security tool, yes. OWASP is pretty good. Burp Suite, there's some things on the slide. If you want to message me on LinkedIn, I can also give you some more. Is Rest Assured a Ghost? I'm not as familiar with that, I must admit. I'd have to, I mean, probably yes in general for APIs. For security, maybe not. So security, you have to think a bit differently. There are some tools that can do security tests automatically. They can generate random data. They can generate random account IDs. They can iterate through all the, /1/account/2, try and enumerate, kind of access them all. that's what a specialized tool would do. I mean, a general REST tool can do any of that stuff. So any REST testing tool can do security and performance, particularly security. It's just going to require more code. You're going to have to write the loops. You're going to have to write the account IDs. So it's up for you. API testing, Ready API versus Postman. I'm familiar with Postman and Ready API. I'm not familiar with Rest Assured. The best, just which you like more. I think Ready API is broader. Ready API can do SOAP, can do REST, can do a bunch of other things. Postman is really designed more for REST. Try them both out, see which one you like. There's no best tool. That just which one works better for you depends what you're doing too. For performance testing, there are things like Load UI for SmartBear. They're pretty good. NeoLoad does API testing pretty well. So a lot of tools do load testing of APIs. So specifically for the load side, Ready API and Postman, they're more functional testing tools, but they could do load. You just have to run it more times. Ready API, I believe, has a load component built in, which I don't know if Postman does. So those are some of my answers. I know we're coming up on the time, so I'm trying to be cognizant. And we're right now, I think, at time. Any other questions?
Yes, we are on time. I don't think there's any other question at the moment. So if any other question comes in, we will drop them at the panel session.
Great.